control any of the tech. That's why I ask so many questions. I only control the schedule in some capacity. So welcome to our second Nerdy Journal Club of the semester. I don't really have any announcements that are related to UAV business. I'm just going to make some quick points about this specifically. So we have a new leadership member, Janelle Sampson, fellow BN classmate, and she's in the Lottie Lab. So yeah, yay. And the only other thing is that if you looked at the schedule, you see that there are a bunch of sessions we've scheduled with research computing. That was in direct response to your feedback that you all wanted more sessions with our data duo, William and Ravi. So welcome to the first one. Now we're fully booked. The whole calendar is full. So join us every Friday. Okay.
All right. Awesome. Awesome. Well, yeah, I think we know everybody here, so that's great. So feel free to stop us anywhere in the middle with questions. We were just going to kind of give a 10,000-foot overview of using R on Chiha, but then also we'll talk a little bit about Git, and then talk a little bit about specific R functions for doing some visualization and data exploration. So kind of diving into, once you're using R on Chiha, what are you going to do with it? So the two websites that you need to know is, one is gitlab.rc.uab.edu. If you have a Blazor ID and password, you can use this LDAP username and password, and you just put your Blazor ID and password in here and you can sign in. If you don't, so like for the folks at Auburn, you can actually register as an external user and have an account on our research computing GitLab instance, and then you can access all this stuff. But we also have made the repository for this particular session public. So actually, if you just have the link, then you can just go straight to it. I don't remember the link off the top of my head, so I'm going to sign in because that way it'll show it. And once you're logged in, you can actually search for public projects and that thing on our GitLab instance. In here, we're going to go to this RC Data Science, R for Data Science. All right. So I'm going to share that link on the Zoom chat, I guess, or maybe I'll just get with you later to share that link so that folks can go to it. Nobody's got a laptop open, so I'm going to assume that it's okay that I don't wait for people to copy down the link. So how many of you are familiar with Git? Okay.
Do you guys use it for your scripts that you write in the lab?
I don't even know what it is. What is it?
Okay, so Git is version control. So you're aware of track changes in Word, right?
Sure.
So when you're working with somebody else, you write your document, you send it to them, they turn track changes on, and then everything they write is highlighted in green, and then they send it back to you, and you can see everything that they've done, and then you can accept or reject their changes. And then when you add more changes, it turns your changes blue, and then when you send it back, and so you can kind of keep track of who's changing what and how it's changing over time. Oops, you okay? All right. So Git basically enables that type of functionality for anything. So it works really well for text documents, things like images or large complicated data sets. It's a little bit harder to track individual changes to it because, like a JPEG, for instance, every time you save it, the lossy data compression is going to change that image a little bit. And so that would require you basically to store a new version of the image every time. But for text documents, it only requires you to basically store like that one line of the text document that changed between versions. For instance, in the Lottie Lab, Will Armstrong manages their data ingest via like a CSV file and a couple of scripts. And those scripts are in an open space that anybody in the lab could theoretically go and look at them and change them for their own purposes. And that has happened in the past. And then he'll go to it, not being a coder, being like, okay, what's going on? My functions suddenly don't work anymore. And so Git allows him to be able to basically do with one command, okay, what has changed in this file between now and the last time that I looked at it? And then he can actually see not only what has changed, but potentially who changed it. And so like if we go in here and look at the history, then we can see that there's a short little history here of me adding things to this repository, and then Ravi also adding some stuff to the repository. And if I click on one of these, like if I click on this early one, then it's actually even going to show me that I deleted or changed this initial line, and then I added all these other lines to it. And then if we go to another commit back up here, then it's actually going to show that I added 2 files. It says that it's showing changes to 2 files, and this is where I actually added the 2 R scripts that we're going to look at today.
Yeah, it basically shows how your script has evolved over time and how many people have contributed, and gives proper authorship to whoever has made changes.
Yeah, and I don't know, have you guys ever experienced a situation in which you're working on a code, everything seems to be working, you get the right results, and then you go to lunch, you come back, you change one parameter, and then suddenly everything's broken and you don't know how to get back to what you did before?
So my side thought is, while version control is great, you know, the rule is there's no such thing, actually it's theoretically proven, there's no such thing as a small change to a piece of code.
Yeah.
If you have a piece of code doing something you like, put it in an archive with a note, because you
Yeah.
never know when you may want to come back to it.
Well, and that's what this allows.
No, in addition to this.
Oh, okay. Yeah. Yeah. No, and that makes sense. And so one of the things that you do as a portion of this is, as you're making changes, you also put notes with every change, because you have to basically intentionally say, okay, I've changed the code a little bit, I'm going to push it to the repository, and here's a note attached with that.
And that's basically
so,
the heading that we have, like initial commit of our script. That's the message that you pass every time you make changes.
No, I get all
But
that,
yeah.
and that's wonderful. These are incremental backups.
Yeah.
Right? Yeah. So everything's kind of encoded together, and that's all fine. But still, if you have a piece of code that's doing what you think you like, and which you're
yes, then you should
put it
copy
somewhere
that,
else
zip it into an
too.
archive so that you're not going to lose it. And there's nothing wrong with doing multiple backups, and that's a great way of doing it. In addition to this, but I would definitely recommend, if you haven't looked at Git at all, look at Git, because also if you do work in a lab space and you have important codes that you've worked hard to do, and your lab is recruiting new graduate students all the time, then from time to time, not all the time, but every now and then, as soon as somebody gets permission, they start fiddling around, and then they accidentally type rm-rf on the command line, and they delete everything that you've been working on for a while. And if you have your data backed up in another place other than Jihad, and your scripts backed up to GitLab, then that will help avoid those situations, or at least give you a way out when those things occur.
And it will facilitate collaboration as well within a lab. I mean, if you are writing a script and you want your PI to see the script and make any comments or something on them, they don't need to be physically right next to your laptop to see what's happening in the script.
Yeah, because I'm not at Ravi's computer, but on here I can click on here and I can see what Ravi actually did in here. And so he went in and added a whole bunch of comments on, and then added more code at the end of it. And so even without Ravi telling me that that's what he did, I can go in and just see that, which is nice. All right. But that's not what today is about. Today is about R. But GitLab is just one of those things that anytime we bump into it, talking about backups and version control is something that we always have to raise our hand and say, hey, we need to talk about backups and version control.
And
it's
it
something,
doesn't look bad on a resume.
Yeah.
If you put it. And
it
the
always looks
skills.
good on a resume. That's very true. In addition to it looking good on the resume, it could save your research career as well.
Yes.
So, it's one of those things that even though we do these things daily, we don't do it enough. So it's kind of like talking about eating healthy and doing exercise. It's not fun, but when you're talking about good practices, it's something that the more we talk about it, the more that we'll do it. And it's never lost time thinking about it. All right, so the next link that you need is if you have a CHIHA account, rc.uab.edu. If you don't have a CHIHA account, you can still go there and it will lead you to a link that will ask you to submit a request for a CHIHA account. But once you're here, you can actually access all of the resources of the CHIHA supercomputer without going directly through a terminal and SSH and all of that business. How many of you have used this web portal? Okay, so pretty much everybody has used it at this point. That's great. So we're going to go to interactive apps, and I don't think any of you use ANSYS or IGV, but those are two recent additions. ANSYS is kind of more of an engineering software. You're probably familiar with ANSYS. No? Okay. All right. I think it's used for like finite element modeling. I haven't used it that much, but the engineering school uses it a good bit. And then IGV is a genome viewer. Yeah, that the bioinformatics groups have requested. So those are two recent additions. But if you've used this before, you've probably already noticed that we have MATLAB, which I know a lot of you use. SAS, which I don't think anybody in here uses. Jupyter Notebooks, which we were requested to specifically not do anything on Python this semester, so we're going to avoid Jupyter Notebooks. It's okay. Our faces did that same scrunchy thing. I was like, why would you want to know about Python? But that's okay. That's okay. We understand. And then RStudio server. So one important thing to know about this RStudio, so how many of you use R in any capacity? Okay. Do you use it on the command line or do you use the RStudio exclusively? Okay.
You have to use command line.
You have to use the command line for some of what you do. Okay, so an important thing about the way that R works on CHIHA is on the command line, it's like it's just installed on CHIHA directly. RStudio, however, wants to be the only version of RStudio running anywhere. And so in a collaborative environment, that doesn't really work because I can't log into the same computer that Matt's logged into and us both run RStudio. And so what we do is we run our RStudio inside of a container, which we can talk about containers another day. If you use the MRI QC tools, I know Omar uses those. Those operate really nicely in a container. It's basically a nice little virtual environment to keep your program working and sane. And so, so this way RStudio doesn't know about all the other stuff. It just knows about what resources we tell it about.
Yeah, so all in all, you should not feel a difference between using R on the command line and using RStudio 99% of the time. There are some packages in that 1% which you won't be able to install in RStudio. If you run across any such packages, either come to the office hours or send us an email and we can figure out how we can get it up for you guys.
Yeah, because and if you ever switch between the two, you may notice some instances, depending on how you manage your library paths and that kind of thing, that act a little goofy. But again, just come to office hours and we'll help you sort that out. In general, though, this is a really nice web interface for it. You can just come in here. For what we're doing today, we're not going to be here for more than 2 hours, so we're going to just let's say we'll do a half hour, because if we're still talking in 30 minutes, we need to be wrapping it up. But we run all of the jobs on CHIHA through a job scheduler, and that's kind of abstracted away, so you're not really seeing that here. You're just seeing kind of what your resource request is. So one important thing to note is, yes, if I choose long, I can type in 150 hours and then I will have this RStudio for the week, and I can reconnect to it at any time. But the job scheduler on the back end gives higher priority to more specific and small resources. So if you realistically are only going to be working for a half hour, and then it's more appropriate and you're going to get your resources faster if you ask for Express and you ask for a half hour. Likewise, you can certainly ask for 24 CPUs and 256 gigabytes of RAM. We have machines that have that on the cluster. But when you do that, you're going to be asking for like 1% of the entire cluster. So that means that the scheduler is going to have to wait until it can find an entire machine that it can give you, because most of the time we're just kind of divvying up small portions of the machines on the cluster to kind of satisfy everybody's requests. So the more appropriate your resource request is, the less time you're going to have to wait for that. So in this case, we're not doing a ton, so we're going to ask for 1 CPU and 4 gigabytes of RAM, which you can kind of think of as like, if you're doing analysis on your laptop and you can still check your email and watch a Netflix show while your analysis is going on, your analysis is probably only taking about 1 CPU and 4 gigabytes of RAM. If, however, whenever you run your analysis, your computer basically shuts down and you got to go cook dinner because there's nothing else you can do on your machine until that's done, then you're probably looking at more 4 CPUs and 16 gigs of RAM. So that's just kind of the mental analogy space you can kind of work with there. And so we're going to click the blue button. Oh, apparently I can't ask for less than an hour on the web interface. So we'll ask for an hour. All right, and so now it's submitted, saying please be patient, but if I refresh this, yeah, it's already scheduled. And, okay, so apparently my last, I abnormally terminated my last R session. It's all right. I'm gonna make these other things smaller. So now I'm using RStudio, and this RStudio works just like RStudio works like on your personal desktop. It's nice because this is running natively in the web browser. So if, for instance, I come over here and I click on this link for this R for Data Science book, I can actually come in here and we're going to start looking at this, let's see, this exploratory data analysis, that's what we're doing. And so I can actually come in here and copy and then paste directly into this window and not have to do any kind of rigmarole of having the window open and then typing it in this other window, which sometimes happens when you're working with like a VNC desktop or something like that. So this is nice because it's just operating directly in the browser, and so we can just kind of treat it as if it's another application on our computer. All right, now that being said, we're kind of going to go back to the GitLab for a moment. When you guys get the link, in order to get the code, if you know how to work Git, you're welcome to figure that out on your own, how to get this code in your own space. Otherwise, you can just scroll down here and then copy this and come, and we're going to look at another part of the portal. We'll go to the job composer here. And I'm going to create a new job from the default template. And then if I scroll down on the right here, I can click Open Editor. And then I can just paste that thing from the README file in here. And what this is going to do is it's going to make this directory RC-DSC, so Research Computing Data Science Club is what that stands for, in your data user directory. The -P here means don't complain if that directory already exists. So that way the rest of the script will continue to execute. And then this might look a little bit involved if you've ever done a git clone before, but the purpose for this is if you do a git clone and then you try to do another git clone over the same directory, you'll get an error. And so this basically just says, hey, if that folder already exists, instead of doing a clone, you want to pull. So that's just going to expect that that directory is already there. So that's that situation. And I don't have Ravi's edits to this code, so I'm going to go ahead and run that job as well. So you can see now down here, I've got that git clone and the git pull. I already have the folder, so it will do this git pull part instead. So I'm going to submit the job. You can see it's queued, but again, that shouldn't take too long. Yeah, so it's already completed. And now if I come in here, I'm going to exit out of my script there, and then we're going to open it back up. Okay. All right, perfect. I think that's got everything in there. So how many of you have used Jupyter Notebooks before? Okay, a couple of you. How many of you have used R Notebooks before? Okay. How many of you know what a Jupyter or R notebook is? Okay, excellent. How many of you get frustrated that when you run your scripts, you have to go look for your graph somewhere else? Okay, so in certain programs like MATLAB, or RStudio does a pretty good job of it because it'll plot your stuff down here. As soon as you type a command, when you execute that command, you get the output somewhere close by. In Python or R on the command line, what ends up happening is you have to run your script and then go look for your data output somewhere else. So an R notebook basically is just kind of R's answer to the Jupyter notebook. And so you get to run your code inside of the script and then see your output inside of the script. And so here you can see here, this is like the default stuff that shows up when you open an R notebook for the first time. So we just left that in there because it's good information, and this is the first time we've done any R notebooks, and so it's like, okay, well, that's helpful. And so so it just gives some information about running things. But for you can always just click this little green arrow, and then it'll actually run stuff. And so then it's just right there in the middle of the script. So it's pretty nice, pretty slick, especially, again, if you're sharing this with somebody that's not super familiar with R, and they might be confused by the whole, my pictures show up in somewhere else when I'm running things, or if you're doing an interactive presentation where you actually want to show things and then maybe able to change some of the parameters of the plots on the fly or something like that. All right, so you'll notice that Ravi put his name in here, and so that's going to cause me trouble. So I'm not going to run this cell. And so Ravi has this in there because if you are running multiple versions of R, then you might run into situations where your libraries conflict. And so this function right here basically allows you to set your own library path. So I think the default is like a .r folder in your home directory. But if you set it manually this way, then it will look in this folder for its libraries. So if I click on this, then it will attempt to look in Ravi's folder for my libraries, but I don't have access to his folder, so it'll just give me errors.
And this method is useful because R is really finicky about the packages and the version of R that you're using. Most of the time, 3.6 package that works for 3.6.1 would not work for 3.6.2. So having separate folders or directories where you can maintain separate libraries for each R version is a great method to have all the.
It doesn't do that automatically for the default. Like it has a 3.4, 3.5, 3.6.
Yes, but if you have 3.6.1 and 3.6.2, then both of them would try to get into the same folder, 3.6.
Yeah, and I have not been impressed with the reliability of it actually creating those new folders. So I recently started using 3.6 and I had a 3.5 folder and it did not make a 3.6 folder. It just tried to look for the libraries in the 3.5 folder and gave me a lot of errors. So I had to manually go in and delete stuff.
Yeah, I'm not familiar with R. It's that brittle? I mean, what is it that changes?
I'm not sure what changes in all of the packages. Maybe there's certain search paths and things. If I would say this, if you're working with one version of R, it's fairly robust in how it deals with the libraries. And compared to things that came before R, it's pretty impressive with how it deals with libraries and things.
Is it just libraries? If the code you write, do they sort of obsolete that, or is that pretty safe?
No. So the code that you write is generally pretty stable, but that's also why we keep multiple versions of R, because your code may rely on the libraries that are associated with a certain version of R. But generally, I haven't found that like the code that I particularly write to be that brittle from version to version. It's more just making sure all of my libraries work together. And that sort of thing. So,
and one of the things we recommend whenever you use any module in Chiha is specify the version that you are using. So rather than just doing module load R, that would always load the latest version of R available on Chiha.
Yeah. So if we install a new version, then your stuff might break.
So if you specify like, oh, I want R 3.6.1. So it doesn't matter if we go to 4.0 or something. Your script is always going to use 3.6.1 version of R.
Yeah.
And it's good for reproducibility, and not just for R. I would recommend that for every script that you're writing, or whatever module you're
Anaconda, FSL, MATLAB. MATLAB is pretty robust between versions. I haven't seen.
MATLAB is remarkably robust.
Yeah, they do a pretty good job of not obsoleting. Like, I think you can still run a lot of codes that were in for 2012 MATLAB in 2019.
Looks great.
Yeah, and I've certainly done that in the last year as well. I've pulled some 10-year-old code from the MATLAB database, and it still seemed to work. So yeah, I would say that R is maybe a little bit more finicky than, it's certainly more finicky than MATLAB. It's more finicky than the Anaconda environments, if you're familiar with those, building Python things. But compared to negotiating like C++ libraries in Visual Studio, it's a dream. So it just depends on where you are in the spectrum of those things. So it's reasonable, but you may run into some problems. Again, if you run into any problems with the libraries or anything like that, just come into office hours and we'll be happy to help you figure that out. So the first time that you run this, you're going to want to uncomment this little piece of code and actually install this tidyverse package. This has a collection of libraries in it that all are related to something called tidy data, which I think is just to make your analysis more robust and readable. And so it's a good package to have. It's got pretty much everything that you would need to get off the ground and running in R. And so now that I've already installed it, I can just make sure I tell R, hey, use that library. Because again, you may have multiple different libraries that conflict with each other, because anybody in the world can write an R library and then submit it to the R repository for libraries, and then you can download those things. But there's no guarantee that tidyverse and library XYZ that Joe wrote in Germany somewhere is going to work well together. They may redefine the same functions or something like that. All right. So here we go. All right. So now we're actually going to start getting into a little bit of analysis. But before I do that, let me just show you. So in the GitLab, there is this link up at the top, this R for data science. And I think you can buy this book on Amazon if you want, or you can just click on this link and the whole thing is an open textbook. And so you can kind of just scroll through it. I don't see, it looks like just towards the very end, they start talking about actually building statistical and machine learning models. But if you're not familiar with R, it really does seem like a decent tutorial in how to get up and running. I mean, it talks about, actually using scripts and some basics in data visualization and things like that. So if you've dabbled in R, but you're not sure where to go next to get a little bit more experience, this might be a good place to look. What's everybody's current favorite way of plotting things?
ggplot.
ggplot. Okay, so you're already using R to do your plots. What do other people use? I know, Omar, you use a lot of Python stuff. Jupiter. Do you use R or do you use Python to do your plots? Python. Okay.
I'm still using MATLAB plot.
MATLAB plot. Okay. All right. So.
Nothing I had to like, so I'm hoping to use ggplot.
Okay. So I would say a bad use of ggplot in R will make your graphs prettier than a good use of, I'm not trying to bash you, Paul, but a good use of MATLAB or Excel. MATLAB's, I mean, I think you have to work really hard to make MATLAB plots look good.
So that's not what I
No,
want
it's
to do.
impossible.
So the time
I use MATLAB plot because I'm lazy, and I just hand edit when I send it off to a journal.
Yes, and even I would say Excel, if you're plotting things in Excel, it's not horrible, but it looks very Excel-y, and there's some aspects of plotting in Excel that aren't great, and there's a lot of stuff that Microsoft, in an effort to make your life easier, does automatically and hides from you and won't tell you how to change. And so the nice thing about R is you can have as little or as much input to the way that your graph looks like, down to, I would like the data portion of my graph to fill X number of millimeters in the middle of my plot. And so sometimes that scares people because they really don't want to know that stuff. But if you have an advisor, I know there's some, so my brother's a professor in engineering, and if any of his students bring a plot to him that is not square, he won't even look at it. Because he's already told them that he wants square plots. It makes it easier for him to put it in papers. And at that point, it's a filtering mechanism. He knows if they haven't made it square, they haven't thought that much about it. So rather than going in depth into here, so we're going to be looking at this exploratory data analysis.
Can you tell me the link for the book?
Yeah, so the link for the book is r4ds.had.co.nz. So somebody very nice in New Zealand put this up for us.
Adley Wickham is one of the authors. He's one of the main guys at our studio now. And
Okay.
He got hired because he wrote most of the tidyverse. He's the
Oh,
guy who
okay.
came up with everything in that.
Okay.
Except for her and I think Stringer. I think somebody else came up with those that he brought back in. But he wrote most everything else.
Okay.
Interesting.
Cool. Very cool. Yeah, we learn stuff every time we do any of these things because, that's the way it goes. All right, so I would say that on your own time, definitely go back. This will actually tell you stuff about the libraries, what tidyverse is, why you want to use tidyverse. Up here in this data visualization chapter, if you haven't used ggplot before, they do a really nice explanation of, creating ggplot. So you start using it, you're already making pretty graphs, and then you start to go back through and they say, okay, like, let's break it down. What are these different pieces doing? And so it seems like a really nice, readable introduction to what it's doing, because I would say that compared to MATLAB plot or plotting something in Excel, this looks a little bit scary, because who the heck knows what geom, point, and AES means? I mean, it's some weird syntax that doesn't necessarily translate directly, but as soon as you start reading a little bit, it's not really that scary. It's basically just saying, what do you want the geometry of your points to look like? And the aesthetics is just like, what do you actually want to plot? Like, what's your X variable? What's your Y variable? And then there's all sorts of stuff where you can add a comma here and then add what you want your dimensions of your graph to be, whether or not you want, like if we scroll down, what you want the colors of your data sets to be, the shapes, whether or not you really want to maintain that gray background. Most of the time you don't want that gray background. You want to switch it to white with black grid lines, that sort of thing. And so, I would say that that's definitely useful. Also, in terms of visualization, if we go, we can also share this link over here. So last year, there was a student that graduated, Melissa Tai. I think most of you know who that is. So she gave a really great presentation on ggplot and using it to make really nice and pretty graphs. And so we actually had her come and give that same presentation to the research computing user group. And as a part of that, we were able to ask really nicely for her to share her master kind of library notebook of all the different visualization things that she would do. And so then you guys can have access to that as well. So you can just kind of go in and steal stuff to make your stuff look prettier. Do you have a question? No. Okay, all right. All right, so now we're going to actually start looking at some data. So the data that we're going to look at is this diamonds data. This is already preloaded into R. So I would say the one thing that what we're showing you today doesn't do, and what that R for Data Science book might not show you, at least not in that chapter, is how to load data, okay? But just so you know, that's not that difficult. Let's just real quickly Google importing a CSV into R. All right, let's see, R data import, R tutorial. Yeah, so right here. So if we go down to CSV file, so this is what it requires. So you just do what you want the name of your variable to be, the equal sign, and then read.csv, and then in quotes the full path to your CSV file, and then your data is imported to R. And you can start playing around with it the same way that you would be playing around with the data sets that we're looking at. All right, so once you've done that and you've got some data in there, then we can start plotting stuff. So ggplot is a generic plotting mechanism through which you can make bar plots, you can make scatter plots, all sorts of stuff. And so that's the other piece that what this geometry thing is specifying. I think when we looked over here, they're specifying a geometry point version, and that'll give you these scatter plots. And then in here we're specifying the geometry bar. So that's saying, hey, I want a bar plot made out of my stuff. And so we'll run that.
Yeah, this is basically to denote categorical data. So there are 5 categories within the data set, and this data set is basically about diamonds that are available and what kind of cut they have. So there are 5 categories available in cuts, and if you are trying to denote categorical data sets, it's good to use the bar maps from ggplot to
Yeah.
show that.
Yeah. Also, things like box plots are not really something that you can do in Excel, for instance. But box plots are something that are natively, you can do that in ggplot with one of these geometry functions. So that's the other aspect of if you're using something like Excel that doesn't natively have the standard plotting types, then R has everything. All right, so so this is basically just showing us that there's a lot of diamonds that were cut into the ideal and not as many cut on the fair. And then this is the same data, but just spit out as a table. All right. And then we'll go down here. And then rather than mapping it as a bar plot, we're mapping now the carats of the diamonds as a histogram. And so the same base data, the diamonds, but all we changed was the histogram, and now we're seeing a histogram instead of a traditional bar plot.
Yeah, and the feature carats is more of a continuous sort of variable rather than categorical. Like earlier we had cuts as fair or ideal.
Mm-hmm.
Now carats can be 0.1, 0.2, 0.3. So that's more of a continuous kind of graphs. That's one of the reasons we are using histograms over here.
All right. So again, you can just very easily take a look at what the bins are here, and then what the counts are in that. Let's see, to choose a smaller bandwidth. Okay, so this is just saying that, hey, you can actually change the width of the bins so you can make your histogram look different.
Yeah, initially I think
so. This is a pretty chunky histogram. But then when we actually make our categories smaller, we can kind of stretch things out. This is from 0 to 5. And then we made our bins smaller and then just looked from 0 to 3. And then suddenly we see we actually have a bimodal histogram instead of unimodal. Is that the right word? I don't know. Histogram. So, all right. And then you can actually put multiple things on one graph. So this one, so again, the ggplot is basically just saying, hey, I want to plot here. And then after that, you tell it what data you're going to be using. And then, let's see, so the geom frequency poly, so I think that's saying that it wants to use a geometry type that is a frequency type, which is like a histogram, but then it's saying that we're going to use more than one data set and do it more like a polygon instead of a traditional histogram. And certainly if any of you have a better idea of what these things mean than we do, it's totally fine to chime in. It's not going to hurt our feelings.
Yeah. And this is useful if you're trying to denote multiple features on the same graph. So in this graph, you'll see we have we are showing the carats plus the cut of the diamond as well. And the cut is basically the color of the graph, and carats is the x-axis.
Yeah, yeah. It's interesting that fair, good, and very good all have more 1 carat diamonds that are kept around rather than smaller carats. And that's probably just because if it's not as good of a cut, you're not going to keep, like, you're not going to be able to sell that diamond unless it's a big diamond. So I think that's probably what's going on there.
And these are the kind of questions that you start having when you see these graphs. So that's why it's called basic data exploration, because right now you're just exploring data. You don't know much about the data, but seeing these graphs, you have these kind of questions. Why is this one always 1 carat? And all similar questions.
Yeah. Like, why are there no diamonds bigger than 3 carats? I don't know. We'll have to go ask the geology folks in chemistry whether or not they know. All right. All right, so now this is a different data set. So they're switching it up. So this is looking at the frequency of the geyser in Yellowstone National Park, how frequently it goes off. And so if I run that, so apparently part of the time it goes off every, I don't know what the x-axis is here.
Just count.
Just
So,
count.
It's just a histogram, right?
Yeah, well, I mean, that's the y-axis is the count, but I don't know what my categories are here. Is
I
that
think
per
minutes.
day?
It should be minutes. Yeah, because generally it's every 5 or so minutes it starts going up.
Yeah.
And I see that there is a big spike at 5,
Yeah.
around 5.
Oh, so actually, no, this isn't the number of times it goes off. It's how long it's going off. Yeah. So thankfully, Robbie put some commentary in here to to let us know what it is. So yeah. So the x-axis is the duration of the eruption. So I think we can actually go up and we could change the x-axis. I'm trying to remember how to do that. Matt, do you remember how to add a label to the x-axis?
Oh, add a label to it?
Yeah, so right now it's
you
just the
add-
name of the variable.
Yeah, so if you go back, just add a plus sign, then another line, then xlabs or xlab, and then
Okay.
just a string, parentheses.
Oh, parentheses?
Yeah,
Okay.
and then a string of what you want it to be.
Okay, so like duration of eruption. Let's try that. Yeah. So again, I appreciate that. It's one of those things that I would have to, like, I Google every time I make an R chart, but in the end, it's not that complicated. It's just a matter of, instead of defining these things graphically through clicking on buttons, you kind of have to use your mental visualization abilities to kind of see, like, okay, what do I want it to look like? What does it currently look like? What do I need to change to get it there? And then just kind of Google for that feature or go bug Matt. All right, so now it's looking back at the diamonds. Okay, so basically they're extending the histogram here to actually look for some outliers. I don't really see anything on there.
So yeah, I mean, one of the things is, if you have a very big data set and you have a lot of observations, then outliers by the definition would be very few in number.
Oh,
So
okay.
if your graph is going till, I don't know, 30,000, and if you 30,000 count and your outliers are 1 or 2, in a normal histogram you won't be able to see, because that would be less than.
Okay, so this is showing that we can actually go in here and limit the axes so that we can actually see where the outliers are.
Yeah.
So this is showing us some that are at 0.
Yeah, another hint
And
that you
showing
have
some
for
over here.
outliers is that if you see the initial histogram, you'll see that there is nothing from, I don't know, around 10 to 60, but it's still showing up in the histogram. That's kind of a hint that there are some values over there. You just cannot see it, so they might be out.
Oh, yeah, because up here you notice we didn't specify anything about the axes, so we're just letting R define those, and so it automatically just says, oh, okay, well, this is the maximum and minimum of your data sets in both directions, and plots that out. But again, I'm sure that all of you have been hammered on presenting plots that don't have matching axes on the same PowerPoint slide. So this is a really good function to know, because you can specify X limit and Y limit. And so then you can make sure that when you're presenting your graphs that they all share the same coordinates, because otherwise it's pretty much impossible to know what the genuine relationship is between those things. All right. All right, so now we're looking at values in DeepLiar. So what is DeepLiar?
It's another one of the packages.
In Tidyverse?
Yeah, it's used to just do the counting and all this.
It's mainly used for data wrangling.
Yeah.
So like
Yeah.
for easy reorganization of data frames
Mhm.
from like wide format to long format. If you want to do it that way, it makes things easier to plot. For filtering, for arranging, for just doing anything that you would have to manually do in Excel. to
Okay,
actually
yeah.
Arrange your data, you can just do it easily with DeepLiar.
Yeah, and that makes sense. And I've used it before, and it has some parallel functions as well, which is nice, especially when you get into larger data sets. But I've kind of done the Google version of using it, where I Google it and it's like, oh, in order to do that, you need to use DeepLiar. I'm like, okay, I'll do that, and it gets done what I need. But then I haven't looked into it much, so I appreciate that explanation. So yeah, so here we're using that package to do some filtering, and then actually arranging by price and by Y, which I'm not sure what the Y variable stands for, but where was that?
You go back down to the call. See, it's just diamonds. It's just part of the diamonds data set.
Yeah,
Which is
let's
a
look
lot
at
there.
let's see, how do we look up info on that data set? Is it
Just do
So we
you-
have smaller that should have all the values.
smaller has all the values? Okay. Still doesn't. There is a function to just get the data description from.
I think if you do question mark and then diamonds.
Yeah,
should
that's
pull
it.
Up the help page for the data set. There you go.
Yeah, there we
And
go.
It should go through all of the variables.
Oh, length and millimeter.
Oh, so the size.
Yeah, it's just the
It's like
size.
actual measurement size.
Okay. Yeah. So apparently there's one really big diamond in our data set.
That's
And,
why they're out there.
yeah, that makes a lot more sense why that's an outlier, and most of the diamonds are kind of small and all gathered together. All right, with that, it's 12:55. We're at the end of what we copied from that R for Data Science book into here. We just really wanted to give you guys a little bit of just reminder about Git, because I know you guys have probably all heard that at some point, or if you haven't, it's good to at least start thinking about. And then also just kind of do a preview of things that you can do with R to hopefully just kind of motivate you, like, hey, it's not hard to use R on Chiha, and using R itself isn't super difficult. There's a little bit of a learning curve, but especially if you're trying to make really nice visualizations, it's a good tool to use.
And
So,
there are
yeah.
more steps mentioned in that book for basic data exploration. There's missing values within a data set and all
Yeah,
that
there's
stuff.
tons of stuff in this book, and so this would not be any wasted time to take a read through this book for sure, because I can pretty much guarantee you that you're going to learn some things in this book that are going to save you whatever time you spent on reading it. So yeah, any questions before we wrap up on the official side of things?
How do you get back to the, you mentioned Melissa's visualization.
Yes. So it is right here. It is at gitlab.rc.uab.edu/rc-training-sessions/r-visualizations.
If you're not able to find it, you can send us an email and we can.
Yeah, and we will also post on our YouTube channel this video that we just made of us talking about R for our data science journal club that we do, and so we'll also post the link that we talked about in the comments of that. And I know Matt and Leland are both taking that journal club as well. So for those of you who don't know, Robbie and I host a an alternate journal club. It's a virtual journal club where we just go through stuff like this once a week, and we just put it up on YouTube and then expect you guys to do it on your own time and then come and talk to us at some point in the semester to show us that you've done stuff. So we're going to be doing that for the foreseeable future. So, it's probably too late to sign up this semester, but I mean, if we end up having 50 people in that seminar at some point in the future, that would just be,
And even if you haven't taken the class, you can go on YouTube and just search for UV research computing and do those videos. And
yeah, because it's just got lots of stuff on how to access the resources on Chiha, it's got a lot of stuff about Python because data science requires a lot of Python stuff. But this semester, we're going to try and do more R and MATLAB stuff too, to kind of catch that up a little bit.
Yeah.
So yeah. All right. Well, thank you guys so much for having us.
So how long